Okay, got a couple of gears here. They have masses, radius of gyration. Basically, I apply a torque to gear A, and I want to find the angular acceleration of both gears, uh, starting from rest after 3 seconds. Okay, so we'll start by drawing a free body diagram here. Now, this is just pure rotation. Right? The center of gravities are not moving. Okay, so there you go. So if I look at Cx and Cy like so, okay, then I have, and I'm just going to call it, I'll go ahead and put it in. It'd be 50 times 9.8 straight down, like so. I then have a moment applied. Put that over here like that. And then what I've got is I've got the force at the edge of the gears. Now, it's pushing down on the right one. That means the right one is pushing up on this one. So we'll call this a force like that. And again, that's going to be equivalent to the same force pushing down on the right one, like so. This guy is going to have a pin joint. That'll be dx and dy. And then it also has a gravity acting straight down of 15 times 9.8. So those are my free body diagrams. Now, I don't really have any force equations. Okay, I don't really care about Cx, Cy, dx, dy. I'm just going to do the moment equations, and I'm going to do the moment equations about the center of gravity, which is the point of pure rotation. So it's really the only choice that I have. So I'll start by summing the moments about C. Okay, and when I sum the moments about C, I have a negative m. Let me take 2 seconds and calculate what m is. When I plug in 3 seconds into that, I'm going to find that m actually equals, and I'll let you do this on your own, but I actually get 90.2 here. Oops, not 9.2. That should be 90.2. Okay, so maybe rather than calling it negative m, I just call it negative 90.2, because that's what the moment will be at 3 seconds. I then have that's a negative moment. I also have a positive moment due to the force at the edge. So that'll be plus 0.3 times that F. And what this is going to equal is I, which is going to be the mass of 50 times the radius of gyration of 0.25 squared, and that's going to be times alpha c. Now this time, I'm just going to be stupid and say, okay, well, I don't know what direction alpha's in. It's going to be negative, but I'm just going to leave it and just say, hey, I don't know. I'll assume positive. I'm going to stick with it, and that'll make more sense when we get moving with the relationship between the two. So now I'm going to sum the moments about D, which the only thing I really have is that force at the edge on this one. So that's going to be 0.2 times that F. And that's going to be equal to the moment of inertia, which is going to be 15 times the radius of gyration squared, like so. And that's going to be times alpha d. Again, I'm going to just be stupid and say I don't know what direction the alpha is going to be in, so we'll leave it like that. Now, I've got 3 unknowns at this point. I've got the force, and I've got the 2 alpha, so I need a third equation. Of course, I know the relationship between these gears, that those alphas at the edge, they have to have the same motion. So that's going to say that 0.3 alpha c equals negative 0.2 alpha d. And again, I don't know which one's positive, which one's negative, but I know that one turns one way, the other has to turn the other direction because of how gears work. So again, I'm just playing stupid here, even though I probably know what direction it is. But again, you just want to be careful about, if you make assumptions, you got to stick with it. So at this point, I'm making no assumptions. Okay, I'll just say, hey, they both have an acceleration. I know the relationship, one's in one direction, one's in the other. I don't know which one's positive, which one's negative. That's fine. But what now I have here is I've got 3 equations and 3 unknowns. Okay, through the magic of algebra, I find that the force between the two is 58.8. I find now what I'm actually looking for is alpha c is negative 23.2, and that will be radians per second squared. Alpha d is 34.8. radians per second squared. Now, again, the negative tells me my assumption that they were both positive. We knew wasn't going to be the case. Alpha, the c is actually the one rotating clockwise, which we probably know because of the moment applied to it. But again, you can make no assumptions, just basically assume they're both positive and then one will be negative and you get it out that way. If I had made the assumption that alpha c would have been negative, when I did my relationship between the two, I would have dropped this negative off, because basically then I would have just been saying, okay, well, I know alpha c is negative, so I don't need to put the negative in there. So again, you just want to be careful with how you deal with the positives and negatives. Any assumptions you make, you kind of want to stick with it as you go through, which can sometimes be a little tricky in these problems.